In this video, we're going to describe the process of factoring by grouping, and we're going to be looking at several examples to give you a better idea of what that looks like. Factoring by grouping is a method of factoring for polynomials, typically who have 4 terms. It's also very useful when you're doing the AC method to factor quadratics whose lead coefficient is not 1, and we're going to see that later on when we talk about the AC method. So in this first example, we have 4 terms, and we're going to group them together, hence the name factor by grouping. I'm going to group this first 2 terms together and group the second 2 terms together. And what that's going to look like is I'm going to go ahead and take the greatest common factor out of these first 2 and the greatest common factor out of the last 2 and see what we have left over. So 12p cubed minus 21p squared. It looks like these are going to share a 3p squared. So when I factor out that 3p squared, what am I going to have left over? Well, looks like I'm going to have 4p minus 7 after I factor this 3p squared out. Okay, now let's go ahead and look at these next 2 terms. So we have 28p minus 49, and it looks like that I have in common is a 7 out of both of those. And when I take a 7 out, it looks like I have a 4p minus 7. Okay, now in this case it was a positive 7 that we took out, so I'm going to put a plus right there. Notice now that what was left over in these 2 expressions, 4p minus 7, 4p minus 7, they're the same. So the way I'm going to finish up this factoring process is 4p minus 7, and then the other set is going to be 3p squared plus 7, and you get that by taking the greatest common factors and putting those in a group together. So in the first example here, we took this 12p cubed minus 21p squared plus 28p minus 49, this big polynomial here, and we went ahead and factored it down into the product of 2 binomials. And we got 4p minus 7, and the other expression was 3p squared plus 7. Okay, so let's look at a second example. And this next example that we're going to do is going to be 12x cubed plus 2x squared minus 30x minus 5. Okay, and I'm going to roll this just like we did before. I'm going to go ahead and group the first 2 terms together and the last 2 terms together. And I'm going to go ahead and take the greatest common factor out here, and it looks like it's going to be 2x squared for the greatest common factor. So what do I have left over after I do that? Looks like 6x plus 1. Now you must be very careful, because if this term right here, any one of these terms, happens to be the greatest common factor, you have to remember to put 1 in its place. Because when you factor a 2x squared out of 2x squared, you're just going to have 1, because 2x squared divided by 2x squared is 1. Okay, let's look at the second set here. We have a negative 30x minus 5. Looks like both of these are negative, so I'm going to factor a negative out. I'm also going to factor the greatest common factor, which is 5, out of there. And what do I have left once I do that? Looks like 6x plus 1. Again, be very careful. Since we took out the negatives right there, it's going to change all the things in here to positive. Also, the 5 divided by 5 is going to leave us with a 1. Got to be careful with those. Okay, so I noticed that 6x plus 1 and 6x plus 1 are the same. So that's going to be one of my groupings. And the other one's going to be 2x squared minus 5. So I have now taken this polynomial and I have factored him down to 6x plus 1 and the other 2x squared minus 5. The last example that I'm going to do is going to be slightly different, but generally the same thing. I'm going to start with 21k cubed minus 84k squared plus 15k minus 60. Okay, and the reason that this problem is going to be slightly different is because before we ever get started, there's a common factor to all 4 of these terms that I can take out. And what is that common factor? It looks like it's going to be a 3. So I can actually factor a 3 out of this problem before I ever get started. So let's look at what's left. I'm going to have a 7k cubed minus 28k squared plus 5k minus 20. Okay, so now I'm going to do the same thing as I was before. I'm going to group the first 2 and the last 2. And for a while I do this process, I'm going to ignore this 3 that I took out, but he's going to come back into play a little later. So of these first 2, it looks like we have a 7k squared that's common, and when I factor that 7k squared out, it looks like I'm going to have k minus 4. Same thing here. Looks like I have a positive 5 that I can factor out, and when I do that, I have k minus 4 again. Okay, again, very nice that these are the same, and in fact, in order to do factor by grouping, they have to be the same. So we have a k minus 4. Our other term is 7k squared plus 5 that we have right there. And then we can't forget this 3 that we took out initially. He needs to come along for the ride, and he goes right out there in front because he was the very first thing that we factored out. So there's factoring by grouping, and hopefully some of those examples right there helped you out.